Alright, for today's lesson, we're going to look at a new method to solve quadratics. So far we've learned 3 different ways of solving quadratic equations. We worked on graphing them, factoring them, and then taking square roots. The last method we're going to focus on is called the quadratic formula. We're going to look at a problem and we'll solve it using the old methods and then use the new method so you can see how it works. It requires a lot of steps, but it's actually pretty easy if you could follow the steps and do it in a logical order. Alright, so for the first one, let's review solving by graphing. So solving by graphing is when you used y1 and y2 on your graphing calculators. So remember the left hand side was y1 and the right hand side was y2. So if you hit y equals, and then you just type in the equation you have. y1 is the left hand side, y2 is the right hand side, and you graph. Remember the horizontal line in this case is the x-axis because y equals 0, and that's when you have the x-axis. So it's crossing at 2 points. To find those 2 points, you hit second, trace, intersect, and you move the cursor. Notice it gives you the location of the cursor on the bottom here, so if you play around with it you can see where it's going. And there it is, the little spider. Get it close to the intersection and press enter 3 times. So one of my solutions is x equals 5. Repeat the process and move your cursor to the left. And then press enter 3 times. So there you have your 2 solutions. That was the first method we learned. The second method was by factoring. And factoring involved using that box. So you could draw a box and place your values inside the box and use them to help you with the multiplication. So remember the first term, x squared, went in the first box, and the negative 15 went in the last box. Now you had to ask yourself what numbers multiply together to give you x squared, and what numbers multiply together to give you negative 15. For x squared, I know it's x times x. For negative 15, I have to list the factors of 15 that multiply to give me negative 15. So 2 easy ones right away are 1 and negative 15, and negative 1 and positive 15. The other option is negative 3 and 5, or positive 3 and negative 5. You're looking for the 2 pairs, or the pair of numbers that will add up to equal negative 2. So the first 2 options are too big of a difference. So clearly it's one of these 2 options. I want the one that's going to give me a negative value, so that's going to be negative 5 and positive 3. So using my multiplication, 3 times x is 3x, negative 5x, and then here in the diagonal, that's where the negative 2x comes from. So your factors are x minus 5 and x plus 3. Remember, we want to know the values that make each of these equal to 0. So I set each of them equal to 0 to find the answer and solve for x. So here I would add 5 to both sides, x equals 5, and here I subtract 3. So again I get the same answer of positive 5 and negative 3. Either method works, it just depends on what you're most comfortable with and what works in the situation. The last method involves this formula, which is the quadratic formula. This says if you have an equation in standard form, which is ax squared plus bx plus c equals 0, then this formula comes into play where you can use it to solve for your x. And basically what you're finding when you use the quadratic formula is you're looking for the values where they cross on the x-axis. You're looking for the solutions when your equation is equal to 0. Sometimes you might only have one solution, and in some unique cases you won't have any solutions. And that's what we're going to explore as we work on this in this unit. So let's take a look at how to use the quadratic formula. It looks kind of intimidating. It's a large formula, but it's actually pretty easy if you can follow the steps. The first thing in the quadratic formula is being able to understand the variables that you use. So remember, standard form is ax squared plus bx plus c equals 0. A, B, and A, B, and C represent variables that are coefficients in front of those numbers, or the last number here, which is the C. So in standard form, your equation starts with the x squared term, and then has an x term in the middle, and then some other number that's being added or subtracted. So let's see if we can identify the A, the B, and the C in each of these equations. My coefficient of x squared is 1. My coefficient of x is negative 10. And then the C value is 20. Doing it again, the coefficient here is 1, 1, and 2. 2, negative 3, and 5. Negative 3, negative 4, and 6. This one's a little different. There's no middle term, so my first one is 1, but then in the middle it's 0 because there's no x term, and then 15. Here it's 1, 6, and then there's no c term, so it's 0. It's important to be able to identify these values because we use these values when we solve. So take a look at using the formula. Here's our original problem. Let's say you're given x squared minus 2x minus 15 equals 0. You could solve by graphing, you could solve by factoring, but now this method we're going to use is using the formula. So first things first, you identify your A, B, and C values. You look for your coefficients and your terms. So A is 1, B is negative 2, and C is negative 15. Now all we're doing is plugging those letters in to the formula that's to the right. This will always be given to you. You will not have to memorize this. So now you can use the quadratic formula to find the solutions. Note the parenthesis around negative 2. You have to use these because negative 2 squared is not the same as parentheses negative 2 squared. And if b is negative, you want negative 2 squared in parentheses. Also notice the split near the end. So let's take a look. Here they're plugging in b, which is negative 2, into the formula. So they have two negative signs because b is negative. So it's negative, negative, plus or minus the square root of, inside parentheses, negative 2 to the second power, minus 4 times 1 times c, which is negative 15, all over 2 times 1. And now they're just calculating, doing the orders of operations. Underneath the radical, they have negative 2 squared, which is 4, and then negative 4 times 1 times negative 15 is positive 60. Adding 60 plus 4 gives them 64. And the positive 2 in the front comes from the opposite of negative 2. The square root of 64 is 8. And now since you have plus or minus, remember we generally have two solutions for quadratics. We have 2 plus 8 over 2 and 2 minus 8 over 2. So if you add that, 2 plus 8 over 2, 2 plus 8 is 10. 10 divided by 2 is 5. 2 minus 8 is negative 6. Negative 6 divided by 2 is negative 3. So again, we get the same solution that we got with graphing and that we got with factoring. Let's try some practice problems together. Whenever you use the quadratic formula, you always identify the a, b, and c values. So in this case, a is 1, b is 8, and c is 15. So now I'm going to rewrite my formula with my values for a, b, and c. So x equals the opposite of 8. Notice I like to put it in parentheses because it helps me remember. Plus or minus 8 squared minus 4 times 1 times 15. All over 2 times 1. So again, whenever there was a b, I was plugging in 8. For the a's, I was plugging in 1. And for c, I was plugging in 15. And then from here, it's just calculations. And one quick step to help you calculate. Whatever's underneath your radical, you can figure out that number by typing it into your calculator without the radical sign, just figuring out what it is when you multiply all that together. So when I multiply this and subtract all this, I get 4. So I can rewrite this problem as x equals negative, and then positive 8 gives me negative 8. So it's the opposite of 8, which is negative 8, plus or minus the square root of 4 all over 2. So now this one isn't as daunting as it initially was when we started. It's not as hard or intimidating. What's the square root of 4? Well, the square root of 4 is 2. So I have negative 8 plus or minus 2 over 2. Once you get to this last step, this is where you can branch out your problem into two separate problems to deal with this plus or minus. You have negative 8 plus 2 divided by 2, or negative 8 minus 2 divided by 2. So negative 8 plus 2 over 2 is negative 6 over 2, which is negative 3. Here is negative 10 over 2, which is negative 5. So in this case, the two solutions are x equals negative 3 or x equals negative 5. Okay, let's try one more. For this problem, we're going to identify the a, b, and c again. So the a is 2, the b is negative 5, and the c is 2. We're going to use those values and plug them into the quadratic formula. Solving for x, so x equals the opposite of b, and notice b is a negative value, plus or minus the square root of negative 5 squared inside of parentheses, minus 4 times a, which is 2, times c, which also is 2, all over 2 times 2. So using your calculator, I'm going to focus on what's inside underneath the radical sign first. That gives me 9. So x equals, the opposite of negative 5 is positive 5, plus or minus the square root of 9 all over 4. The square root of 9 is 3, so that's plus or minus 3 over 4. And now you can branch it out. 5 plus 3 over 2, or 5 minus 3 over 2. 5 plus 3 is 8. 5 minus 3 is 2. 8 divided by 2 is 4. 2 divided by 2 is 1. So you get x equals 4 or x equals 1. And there's your quadratic formula. Try some of the other problems on the practice sheet. Make sure when you're using your calculator that you be very careful with how you're entering in your numbers. And then remember, you can always check, you can try factoring or you can try solving by graphing. Good luck.